Okay, everybody, in this video, we are going to use the P approach in testing to see if the data is statistically significant or not. Same exact question as the previous video. This is 10.3, page 3. Here we go. So the null hypothesis is that the average is 63.3. We want to show that the average is greater than that, so somewhere above that, okay? So if it lands on 63.3, we will accept the null hypothesis. If it's greater than that, we will reject the null hypothesis and keep the alternative one. Using the t-distribution table to estimate the p-value for this point estimate of 64.2. So just like the last computation, we take our 64.2 minus 63.3 divided by 2.2 over the square root of 40. Those are our values for this particular problem, and we get to 2.587. Now, I know on the notes, the completed notes talk about, let's shove this into our calculator. Our TI-36 calculator does not have the T-CDF button, so we are unable to use it for that. So I have to show you how to use it, the chart. Good news, we've been using this chart for a lot of different problems. We want to find the confidence interval for this particular T value. So we have to reverse look up this T value in our chart. Again, this is Appendix A14 on our e-text. You might want to print one out or have that readily available. I know on Pearson it's available for you just with a click of the button. So we have to find the confidence level based on a degrees freedom, and that formula is the same since section 9.2. The degrees of freedom is always, that's right, n minus 1. In this sample, there were 40 women selected, so 40 minus 1 is 39. That's the degrees freedom. If the degrees freedom is not on our charts, then we are going to use the one that's closest to it on our chart. So let's go to a degrees freedom 39. That's this row right down here. And we're looking for a T value of 2.587. To find 2.587, ooh, there's 2.4, there's 2.7. It's somewhere in between there. 2.587 is between these two marks. So now we go vertically up in this chart, and we know that our answer is somewhere between 0.01 and 0.005. So we're talking about 99% sure or 99.5% confident. Let's take a look at what that would look like as an inequality. Our p-value has to be greater than 0.005 and at the same time less than 0.01. Again, those two values come from our chart. Now let's compare that in part C. Using a 0.01 significance level, do we reject the null hypothesis and then write a conclusion? Since our p-value is going to be less than 0.01, it is in that zone above this value. So our null hypothesis said that it was exactly 63.3. It's not. It's bigger than that. So based on this, we reject the null hypothesis. The conclusion, we conclude that there is sufficient evidence at the confidence level of 0.01 to say that women are taller today than they were in 1990. Two different approaches for the same exact problem. I hope this video is helpful for you guys. Remember, email me with any of your questions I'll try to answer them as quickly as possible. Talk to you soon.